All right, I am here with Valve Technologies at 2022 RefCom, here with Mike Murphy. Thank you, Mike, for joining us.
My pleasure.
I want to take some of the opportunity to showcase for our audience some of the unique aspects of the Valve Technologies ball valves. So you have this great demo here. Let's just kind of give the folks at home just kind of an overview of what is really unique about your valve.
Okay. One thing unique is I've traveled the world, and one of the most common failure modes I hear on coker valves is coking up instead of leak by, which is primarily what you hear in other applications. So the key to have a good purge design is imperative to get the runtime that a lot of customers are looking for with these valves. So what we've done on our valve is we have what we call a live flushing purge. And the whole idea of the design is to do removal of hot oil or coke fines in the cavities, which eventually will turn to solids and interrupt the operation of the valve. So we bring our steam in here.
Spin this around for our folks here. Come over, there you go. So bring the steam in.
Yeah, we have a manifold that we can offer, so the customer can only bring in one pipe, one 9-chrome run of pipe, okay? Then, so the steam comes in, kind of get a better view here, and it hits the ball and gets into a lot of turbulent, swirling flow. And that's what we want, because we want to get a high velocity movement within these cavities between the ball and the casting, and then remove it back through this bypass. So we're getting a lot of movement, and we're getting displacement or removal of any hot oil or fines back through this bypass into the waterway of the valve. So that's very important. Say it's an inlet feed valve, you're in at reaction temperature, you go to close to switch to another drum, you start getting cooling to steam temperature, and that's when some of your solidification can take place. So if it's removed and displaced, then you don't get the solids build up, and that's what this purge design provides.
Yeah, so basically when the valve is in its closed orientation, basically when you go from open to close, there's going to be stuff in here, right?
Correct.
I mean, even if the operator does the right thing and purges it for X number of minutes to keep it clean, there's always going to be a little bit left behind, right? So what your strategy is to take it out of here and push it back into the process.
Correct.
That's pretty clever.
Correct.
Pretty clever. So one of the things I also want to take the opportunity to focus on now is you got this little blue ring right here. So that's the seat, right?
Right, right.
So you have an active seating side and a static seating side.
Right.
So can you walk us through the sort of normal single seat design and then your bidirectional seat design?
Okay. This seat on the unidirectional, or one seating non-bidirectional side, takes a spring load. There's a Belleville spring back here that when we bolt the body halves together, it compresses the spring, loads up a spring rate that we have by design for shutoff and to keep particulate from migrating in these seat faces. So the spring will load the seat loads the ball to what we have as another unique part of the valve is what we call an integral seat. We machine the seat into the body half, and we eliminate a seat ring, which you have to manage 2 leak paths with a seat ring. We eliminate that with the integral seat design.
Okay.
So that's unique there. Then if you want to go bi-directional, which we've had some applications, we've actually done a job years back in about 2007 at a refinery in California where they only wanted one single block on the blowdown application. So they were concerned about pressure coming back from the blowdown system and of course the pressure coming from the drums. So we made a bi-directional modification to this valve, and what we do is we modify this seat ring, we polish it to the ball as well as we do this seat. We hard coat it with our chromium carbide coating technology we do at Valve Technologies, and then we put some graphol seals on the OD to seal OD, and then you seal at the face here. It's a little bit different modification than the integral seat, but so that's what we've done for bi-directional applications.
Metal to metal on one side, and then it's graphite on the other side.
Yeah, to manage the leakage coming on the OD of the seat.
Okay, I understood. So just to focus on that for a second, just to make sure everybody caught it, there's an application where normally you would have 2 valves, right? Going to the blowdown, almost always we'd have 2 valves, but because of it was an older unit, they didn't have the piping configuration, they didn't have the space, to put two big valves. They said, we need to go out to the market, we need to find something that'll be safe for only one valve. So you came up with a solution, and that was when, back in 2007?
2007, 2008. It was an automation project upgrade to go from manual valves to automation, about that time when all the interlocks started coming into play.
Sure, yeah.
And you said it right. It was an old coker. They didn't have the space, so they made the decision to go with a single block.
Mm-hmm.
And that valves, they're just now starting to pull them out of process, and they've been in service about 13 years. So the valve did its job.
Okay, well, maybe next year we'll be able to convince you to come back and talk about the overhaul.
There you go. There you go.
But so there's other applications for this bidirectional valve as well, such as, for instance, with multiple drum module cokers, like if you have 4 and 6 drum cokers, if you actually have to take one of the, let's make sure I use my words right, downstream fractionator isolation valves out of service, that's a full unit shutdown, right? But we want to avoid that as much as possible. So people are actually starting to use valves of this configuration, again in the bidirectional mode, to be where the two fractionator lines come together in what we call the common line. They'll drop one of these in here, and now all of a sudden they have the ability to do a positive isolation, get to so-called SP2 valves without having to shut down the whole unit. And I know recently we've worked on one project where they're just doing this right now. Have there been a number of sites where you've done that?
Yeah, we've done it 4 refineries, actually 5. One was very old up in Lamont, Illinois. Very old,
Yeah.
back in the 90s, actually.
Sure, yeah.
Most recent would be one in California and one in Colombia.
Okay.
Same philosophy you're talking about. Now, we did do bidirectional on those valves because they were concerned about pressure maybe coming back from the fractionator, and of course on the drum side as well.
Sure, yeah.
So those were bidirectional design valves there too.
Well, very good. Well, you showed us a little bit about your clever purge design, a little bit about your seat configuration, and thank you very much, Mr. Murphy. It's been a pleasure. Thanks